student, good morning. This is Dr. Rajinder with you. I am going to record my first lecture on joint probability distributions. Before I begin, I want to give you a quick review on the items which you already studied in chapter number 3 and 4. My dear students, as you know that in chapter number 3 we studied discrete probability distributions and the variable taken under consideration over there was a single discrete random variable. I would like to remind you that the term which I associated with that discrete random variable was a probability mass function. Similarly, in continuous probability distribution, the variable taken under consideration was a continuous random variable, and the term which I associated with that continuous random variable was a probability density function. So it is now understood that whenever we talk about a probability mass function, so the variable taken under consideration is a discrete random variable, whereas in case of a probability density function, the variable taken under consideration is a continuous random variable. In this chapter, we begin by considering random experiments in which two random variables are studied. In later section, we generalize the presentation to the joint probability distribution of more than two random variables. In the term given on the top, joint probability mass function. So probability mass function, you already familiar with it, so the new addition is the word joint. So in joint probability mass function, the variable taken under considerations are more than one and they are discrete random variables. So let me define JPMF. The joint probability mass function, briefly known as JPMF, of the discrete random variable x and y, denoted as f of xy, satisfies these conditions. Condition number 1, that all the functional values should be either 0 or bigger than 0. The condition number 2, which is very important, when we collect all the functional values, the answer should be a unit or 1, because as mentioned in condition number 1, that the values of function should be either 0 or bigger than 0. So when we talk about 0 or bigger than 0, so bigger than 0 value may be reached until plus infinity. So the role of second condition is very important, because it says that when we collect all the functional values, answer should be a unit or 1. So later on we can use these joint probability mass function to find out the probabilities of two or more than two discrete random variables. Before answering the question, let me give you a quick review. When we say that a given function is a joint probability mass function, the first condition, that all the functional values should be either 0 or bigger than or equal to 0, and the second most important condition, that when we collect all the values of the given function, the answer should be a unit. So let us now answer question number 1 given on the exercise for section 5.1 on page number 167. So I'm going to read the question as I usually say that first of all understand the nature of the question and then try to start your answer. So the statement of the question is, show that the following function satisfies the properties of a joint probability mass function. The data for two discrete random variable and the value of function is given in a tabular form, and once you verify that the given function is a joint probability mass function, the second part is to answer the questions starting from part A until part E. So let us first answer the hidden question, that is verification whether the given function is a joint probability mass function or not. So what we have to do, first of all, we have to look for the functional values, means the value of all the values of the function, and it should be either 0 or bigger than 0. So from the table it is clear that all the values of the function are bigger than 0. So first condition is satisfied. So let us now satisfy second condition. What is the second condition? We know that the second condition says that sum all the functional value and sum should be 1. So let us collect all the functional values. The first functional value is 1 over 4, second one 1 over 8, third one 1 over 4, fourth one 1 over 4, and the fifth one 1 over 8. When we collect all values, we will get a 1. So from the table it is clear that all the properties of JPMF or joint probability mass function are satisfied. Therefore the given function is a joint probability mass function. So we'll use now the joint probability mass function values to find out the probabilities asked in part A until part D, and later on the mean and variances for the two discrete random variables. So let us have a look on the question given on part A. The question is probability of x less than 2.5, y less than 3. So what we have to do here, we have to find the probability for a discrete random variable x less than 2.5 and a second discrete random variable y less than 3. So my dear students, let us first of all see how many values are less than 2.5 under x. So we will find out three values, that is 1, 1.5 and 1.5. The next value is 2.5. Be careful, 2.5 is not included because the question says that x should be less than 2.5. So we have to choose 1, 1.5 and 1.5. Now we have to see now the value of y corresponding to x. So for that we have to see the condition or restriction imposed on y. So what is the restriction imposed on y? Y less than 3. So how many values we have y less than 3? 1 and 2. You see here from the table, the first value under y is 1 and the second value under y is 2. The third value is 3, and in the question it is clearly mentioned that y should be less than 3. So we end up with 2 points, x equal 1, y equal to 1, x equal 1.5 and y equal to 2. The third point, x equal to 1.5, is correct for x less than 2.5, but for y equal to 3 it is not correct. So we have 2 points. So let us now write down the values of the joint probability mass function for x equal 1 and y equal to 1, and after that x equal to 1.5 and y equal to 2. So we have two values, first one 1 over 4 and second one 1 over 8. So let us collect both the values. When we collect both the values, when we sum both the values, we'll get 3 over 8. So it ends part A. So here is part B, and if you look at part B, it says that we have to find the probability of x less than 2.5, and there is no y. It means that there is no restriction, no condition on y. So we have to select all the values less than 2.5 and then the corresponding values for y. So x less than 2.5, we have three values, 1, 1.5 and 1.5. So since there is no restriction on y, so we can choose 1, 2 and 3. Means for x equal to 1, y equal to 1, for x equal to 1.5, y equal to 2, and for x equal to 1.5, y equal to 3. So we have now the corresponding joint probability mass function values for 0.11, 1.52, 1.5 and 3, and these JPMF values are 1 over 4, 1 over 8 and 1 over 4. So when we collect all the three values, we have the answer 5 divide 8. So we already answered part B. Now let us answer part C. Try to understand the question first. It says that we have to find the probability of y less than 3, means all those values of y which are less than 3. So there is no restriction on x, so x value you can select according to the value of y. So let us see how many values we have under y. Y equal to 1, yes in, y equal to 2, yes in, but y equal to 3 not allowed, because the question it is mentioned that y should be less than 3. So for y equal to 1, we have corresponding x value 1. For y equal to 2, we have corresponding x value 1.5. So we have again 2 points. So let us now write down the corresponding joint probability mass function values, and after that we collect both the values and we will get the final answer. So the first JPMF value is 1 over 4 for the point x equal to 1 and y equal to 1, and for x equal to 1.5 and y equal to 2, the functional value is 1 over 8. So when we collect both the values, we will get 3 divided by 8 as our final answer. So the next question, my dear student, is part D, and it says that we have to find the probability of x bigger than 1.8 and y bigger than 4.7. So let us see how many values under x which are bigger than 1.8. So we have 2, 2.5 and 3. So what about y? We have only one value, because y should be bigger than 4.7, so we should ignore 4. So we have to consider 5. So we have now two values, x equal to 3 and y equal to 5. So the corresponding probability joint probability mass function value is 1 over 8. So the final answer is 1 over 8. To answer part E, basically part E consists of 4 subparts. It is a long question. It is easy, not that much difficult. So to answer part E, first of all we should understand the nature of the question, that what is the demand. The demand is to find Ex, Ey, Vx and Vy. So you should understand what is the meaning of E of x. You know that the meaning of E of x is the average or mean of x. The meaning of E of y is the average or mean of y. The meaning of V of x is the variance of x, and the meaning of V of y is the variance of y. So we have to find the mean and variances separately for x and y. So let us first find the mean of a discrete random variable x. uh, the first three columns consist of the information provided by the author in the question. So what we have to do here, we have to multiply all the values of 1, all the values of x with f one by one, and at the end sum it to get the mean for x. So similarly, when we have to find the mean for y, take under consideration all the values of y, multiply one by one with their corresponding joint probability mass function value, and sum it to find the mean for y. So let us start with e of x. So what is the first value under x? 1. So 1 multiplied by the corresponding value of joint probability mass function, which is 1 over 4. So 1 into 1 over 4 gives us 1 over 4. I already have made a column for x into f. So second value 1.5 multiplied by the corresponding value of 1 over 8. So it gives us 3 over 16. You can use the calculator for the calculations or the simplification. So proceeding the same way, for x equal to 1.5 and f equal to 1 over 4, we have 3 over 8, and then the next 5 over 8, and at the end 3 over 8. So we have the different x multiplied by f value for different values of x and f. So now let us collect all these values to get the mean value. So for your convenience, I have written over here, I started with 1 over 4. I keep on adding the next value like 3 over 16 plus dot 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 until 3 over 8, and I got 29 over 16, and in decimal form it is 1.8125. So this is our mean of a discrete random variable x, or simply you can say that e of x. We'll use this mean to find or calculate the variance of x. So in the next slide, for variance of x, we proceed as follows. This is the rule for variance. Variance of x equals sum of x square into f minus mean of x whole power 2. So be careful, my dear students, when you have to find the mean variance for x, you need the sum of x power 2 into f, means the square of the values of x, and multiplication with their joint probability mass function values, and sum all the values, all the result, then minus square of mean of x. So let us try column number 1 2 3 4 we already finished in the previous slide. So we will add, since we need, if you look at the formula, we need sum of x square into f. So let us add one column and name it x square into f. So x square, so what is the value under the first value under x? 1. So square it 1 power 2 and multiply with f. So what is the corresponding value of f for x equal to 1? 1 by 4. So 1 power 2 into 1 by 4 equal to 1 over 4. So similarly, repeat the same process for second value of x, and we will get 1.5 power 2 into 1 over 8 equals 9 over 32. Proceeding in the same way, we'll get 9 over 16, 25 over 16, and 9 over 8. So now you see we have different entries for x square into f in this table. So since our requirement is sum, so we'll collect all this value to get sum of x square into f. So I collected and I got 121 over 32. So let us substitute the mean value and sum of x square into f value in the formula of variance of x, and let us see what happens. So I will replace sum of x square into f with 121 over 32 minus mean of x with 29 over 16 whole power 2, and the output is 127 over 256. After using the calculator, in the decimal form we have the variance as 0.49609375. In the previous two slides, we found out the mean and the variance for a discrete random variable x. The third and fourth sub part to find mean of y and variance of y. So to find mean of y, we proceed as follows. My dear students, the steps, the procedure remains the same, only we have to choose here the y value. Earlier we select x values, we multiply x values with the corresponding joint probability mass function, we sum it to find mean of x, and so let us find the mean for a discrete random variable y. So since we have to find mean of y, so this time we have to consider the value under y. So what is the first value under y? 1. So 1 multiplied by the corresponding value of joint probability mass function, that is 1 over 4. So 1 multiplied by 1 over 4 equal 1 over 4. Repeat the same step for y, second value of y, which is 2 multiplied by 1 over 8, and after the simplification will get 1 over 4. Proceeding in the same way we'll get 3 over 4, 1, 5 over 8. So when we have to find the mean, what we have to do, we have to collect all the values of y into f. When we sum up all the values, we found out 23 over 8, and in decimal form it is 2.875. so 2.875 is the mean value for a discrete random variable y. Let's find the variance of y. For variance of y, we proceed as follows. We use the same rule, but replace x by y. Variance of y equal to sum y square into f minus mean of y whole power 2. So we already have done until mean of y in the previous slide. So we will add one more column in this table and name it y square into f, because we need sum of y square into f value. So what is y1? Square it. When we square 1 power 2 1, and then we have to multiply with the joint probability mass function value. So 1 power 2 into 1 over 4 gives us 1 over 4 again. Then the second value, which is 2, 2 power 2 multiplied by 1 over 8, we'll get 1 over 2. Proceeding in the same way, we'll get 9 over 4, 4, and 25 over 8. So let us collect all the values. Let us sum up all the values of y square into f. We end up with 81 over 8. For your convenience, I already have written over there 1 over 4 plus 1 over 2 until 25 over 8, and after simple calculation we will get 81 over 8. Now we have y square into f, sum of y square into f value. We have mean of y. Let us insert these values in variance of y rule to get the final value of variance of y, for variance of y. So 81 over 8 minus 2.875 power 2 equal 119 over 64, and in decimal form it is 1.859375. So it ends our part E. I hope students, you got almost 100% of the idea on joint probability mass function. So let us give a try to the next question, that is 5.2, given on the same page. I'm going to read the question. This is little bit different from the earlier one. In the earlier question, the data in the tabular form was given, but here the data is not given, so we have to prepare a table. So let me read the question. Determine the value of c that makes the function f equals cx plus y a joint probability mass function over the 9 points with x equal 1 2 3 and y equal 1 2 3. So it is already mentioned in the question that we should have 9 points. Now how you see how x varies. X starts from 1 and goes until 3. So 1 goes to 1 will be the 1 point. For example, x is 1, y is 1. So 1 1, x equal 1, y is 2. So 1 2, x is 1 and y is 3. So 1 3. So let us enter x 1 1 1 2 2 2 3 3 3 and y 1 2 3 1 2 3 and 1 2 3. So the given function is f equals cx plus y. So when we put x equal to 1 and y equal to 1, we will get 2c. When we put x equal to 1 and y equal to 2, we will get 3c. Proceeding in the same fashion, proceeding in the same manner, we will end up with the last point 6c after substituting x equal to 3 and y equal to 3. So let us collect all the values. When we collect all the values, we'll get 36c. Now the question says that determine the value of c. We know that for joint probability mass function, sum of function values equal to 1. So in place of, so let us substitute. We know that just now we calculated sum of f, which is 36c. So we replace this double summation by 36c, divide both sides by 36, and we'll get c equal to 1 over 36. So just put c equal to 1 over 36 here, and we will get the new function, which is 2 over 36, 3 over 36, 4 over 36, 3 over 36 until 6 over 36. So we have a table now, and we will use this table to answer given in this slide. My dear students, the idea is same. You have a table, you have all the information in the table in the previous slide. Kindly use the idea which I discussed in question number 5.1 to answer all the questions given in this slide. If you have any difficulty, any query, you can just send a mail to me. I will try to help you. We are using as a test book applied statistics and probability for engineers. Thank you very much.